electricity is the #1 cause of CO2 emissions in the United States. It's pretty inefficient, right? It's like stepping on the gas, stepping on the brake, stepping on the gas a lot to affirm some of that frequency, to do some of the challenges that you have to do in order to actually serve the load. Utilities have a tough time, right? By definition, they have to serve everybody in their constituency. They have to do it all the time, and they don't have control over that. We use 12 billion gallons of water every day in the United States as a part of generating electricity. It's about 15% of the total water usage in the U.S. That figure is about 6 years old, so it's probably more by now. So electricity is our ultimate just-in-time commodity. What we're seeing here, what we're looking at on the screen is a millisecond old. And in general, if you don't use it, you lose it. So if you were able to somehow decouple and not have it instantaneous, all sorts of great stuff happens. Great economic stuff and great environmental stuff. If you have a warehouse where you can warehouse electrons and store them for later, then you can do what warehouses have helped other industries do. Manufacturing, beverage, gas, banking, all sorts of good things come when you can decouple where you generate and where you use. Primus Power is a 2-year-old development stage company. We have a flow battery. It's a liquid battery. The battery itself is about the size of a hot water heater, about 30 inches diameter, about 6 feet tall. The bottom 2/3 is liquid. The top third is our reaction chamber. We flow into and out of the reaction chamber. We plate zinc. In the process of plating zinc, it takes electricity, and when we want electricity from the battery, we take reverse or process. We ship 32 of our energy cells, as we call it, in a 40-foot shipping container, and that's about a megawatt in a box. A big box, but a box, a standard shipping container. That compares to what Martin is standing next to. Martin is standing next to a 8-megawatt generator. It's a natural gas generator. It is huge. Martin's 6'4". His hard hat makes him about 6'7", so he's a pretty intimidating guy. That thing spews out all kinds of nasty stuff. It takes lots and lots of water on an annual basis and millions and millions of BTUs of natural gas. It firms wind. They have 6 of those in Modesto. Primus has 2 rounds of venture capital funding and is the fortunate recipient of 3 government grants. One of our grants is a $14 million grant to help build a 25-megawatt battery. That'll be about 40 of these shipping containers. Bring it to Modesto and do the same thing that 6 of these natural gas generators are doing. Those natural gas generators are in a building that you see there in white. You can see 6 sets of smokestacks. That gives you an idea of the size of that system. We can do the same thing that those 6 generators do in about 1/8 of that space. And oh, by the way, we don't have emissions. Eric asked us to think about the obstacles and talk about the obstacles here. The main obstacle here is money. It's all about the Benjamins, baby. We need to get the cost down, and one of the ways that I like to show that and talk about that is to show in every graph that looks at this market. This is an elastic market. Certainly all the Stanford students here know what that means, that it will grow disproportionately to the cost. If the cost halves, the market's going to grow by more than 2, right? The market today is somewhere, round numbers, around $3,000 per kilowatt hour. And that's a nice little sliver there, and if you look at the lithium-ion batteries and the flywheel systems that are out there, they're serving that because the need is greater. It's around $4,000 per kilowatt hour of value, and you can sell the system for $3,000 and everybody wins. The folks selling the system wins, the folks using the system win. But it's a really tiny market, right? That's not a really interesting market. It's maybe a couple hundred megawatts. What you need to do is you need to get the cost down to something around $1,000 a kilowatt hour, because then that market becomes double-digit gigawatts and double-digit billions, and it is much more interesting. I don't know if it's going to take 10 years to get there. We certainly are going to get there sooner than 10 years, one way or another. And we hope to be able to serve both short-duration applications like the ones on the left of this slide, as well as longer multi-hour applications. So is energy storage crucial? Absolutely. There are a number of economic benefits. There are a huge number of societal benefits. There's a ton of waste in the system. We can help take out the waste, not all of it, right? There will be some waste, but we can greatly reduce the waste. Energy storage is a critical part of a smart grid. Primus Power, thank you very much. We're in it to win it. Stay tuned.